This is the fourth part of our review for the Molecules to Atom Physical Science Unit 1 test. And we're going to talk about ions versus isotopes in this particular section. Okay, so some key ideas to remember in this particular section are that ions, the word ion means the particle is charged or a charged atom. And when we look at this, that means that the number of protons and electrons will be different. Typically, atoms are neutral, so unless otherwise indicated, they will always have the same number of protons and electrons. Isotopes are atoms of an element which have a different number of neutrons. You can think iso means same type. Recall that the atomic mass on the periodic table is a weighted average. So it will be closest to the most commonly occurring type of atom. However, it does not represent any particular atom specifically. The decimal helps us to remember this because we can't have a fraction or a decimal of a proton or a portion or a decimal of a neutron. We've talked about, not having halves of objects like this. You can't have a half a proton or a tenth of a proton. It doesn't make any sense. All right, so let's take a look at an ion. An ion is a charged atom. Electrons and protons are the only charged particles in the atom. So to determine if an atom is an ion, we're going to compare the number of electrons and protons. If they're the same, then the atom is not charged. If we have the same number of protons and the same as we do electrons, then the atom is not an ion. It's a neutral atom. Neutral. No charge. If the number of electrons is larger than the number of protons, electrons are negatively charged. So if we have more negative charge, then clearly we are negatively charged, and we would be then a negative ion. And we'll talk later about specific terms we use for that, but right now, negative ion is fine. If the number of protons is greater than the number of electrons, we have said in the past we have a shortage of electrons in that case, then the atom is positively charged. Protons are positive, so if we have more protons, we are positively charged or a positive ion. And you can see on the bottom here, we're comparing the number of protons to electrons. So I'm going to look at this again. Most atoms are neutral. However, we're going to discuss this idea of having charge on an atom because it comes up with bonding later. And I'm going to come down to these examples on the bottom, and we're comparing the top number and the bottom number. So I'm just going to scroll up a little box to block out those neutrons. So here we're neutral. We have 6 protons, 6 electrons, same protons, same electrons, neutral. No net charge. They kind of cancel each other out effectively. On the next one, again, comparing protons to electrons. We have 5 positive charges, 6 negative charges. So there's more electrons, more negative charges than positive charges. So this is a negatively charged atom or a negative ion. All right, and then again on the last one, 6 protons, 5 electrons. These are positive charges, those are negative charges. More positive than negative, or positively charged. And you'll need to be able to do this yourself. It takes time. Make sure you're comparing the protons and electrons. That's the important piece. All right, let's review information from the periodic table. Make sure that you recall what your terms were and can find the information. So we have a 1 or 2 letter abbreviation to represent the chemical name. And that would be the element symbol or symbol. We've most commonly called it element symbol, but this is fine. All right, and then number 2, the element's common name. And that one kind of gives it away. That's just the element name or the name of the element. All right, number 3. This number right up here is equal to the number of protons in the nucleus, and in general, the number of electrons that we'd find in the electron cloud. This again is unless specified otherwise. The atoms are neutral, so what is that number? That's the atomic number. The atomic number is equal to the number of protons. This piece down here, the number of electrons, is only in a neutral atom, so please don't memorize it as though this is always true, because that's not always true. All right, number 4, weighted average of the masses of all elements isotopes. And that is the atomic mass. Remember, this is an average, it's not any particular one. Again, it says rounding the atomic mass to the nearest whole number yields a mass number, most common, which is the most common isotope, mass number of the most common isotope. So that kind of gives away number 5 a little bit, but let's see if you can get it. The sum of the numbers of protons and neutrons in a specific isotope. And that is the mass number. Just like it says here, we take this atomic number, we round it to the nearest whole number. That tells us the total number of protons and neutrons. We can't have 0.011 of a proton or 0.011 of a neutron. It doesn't make any sense. So we're going to round it to the nearest whole number. Remember, 5 and above, give it a shove. You move it up, round it up. 4 or below, let it go. If you've got 4 or less on this first decimal place, you would just drop it off. If you've got 5 or more, you would round it up. So since this is a 0, we just let it go. So that gives us 6 protons, right? 12 total particles, 6 protons. So we have 6 neutrons in the nucleus of this carbon atom. Remember, whole numbers, not decimals, for the mass number. Okay, next. Not all periodic tables look exactly the same. You need to get a little used to the information floating around and not necessarily being in the same order. We're going to take time to practice with this. So here are the questions. I want you to take a moment to answer these questions. What is the element name? What is the element symbol? How many protons does this element have? How many electrons does a neutral atom of this element have? What is the atomic mass of this element? What is the mass number of this element? How many neutrons does the most common atom of this element have? I'm going to give you a minute to look this over and try on your own. Now I'm going to go ahead and get started, but at this point, if you need to, pause it and finish up. But I'm going to go over these answers for you as well. What is the name of this element? Well, the name is right up here. It is molybdenum. Molybdenum. That is the element's name. What is the element symbol? Well, it's right here. And please make sure that you write it exactly as you see it. It is uppercase M with a lowercase o. Please be careful. It is not capital M, capital O. That second letter has to be lowercase. Some students are not real careful or they write all in uppercase. This is one time when that makes a big difference. So please get out of the habit for this unit. How many protons does this element have? Well, for the number of protons, I'd look up here. This is the atomic number. It'll be the smallest number on that in that block. And so it is 42. Atomic number is the number of protons. Remember, that's how the periodic table is arranged. How many electrons does a neutral atom of this element have? Well, neutral means same number of protons and electrons. So if I have 42 protons, then I must have 42 electrons in a neutral atom. What is the atomic mass of this element? Atomic mass. Well, the atomic mass is that decimal number that's right down here. So the atomic mass is 95.94, and the units are atomic mass units. We've talked about this a couple times, but we haven't spent a lot of time focused on it. But that is the unit that we use, 95.94 atomic mass units, or AMU is a way you'll see it abbreviated. What is the mass number of this element? Well, for the mass number, we take a look at this atomic mass and we round it to the nearest whole number. Whole number. So it's above 5, that 9 tells us we're going to round it up, so it is 96. 96 is our mass number. How many neutrons does the most common atom of this element have, or most common isotope, we could say, have? Well, recall the mass number tells us the total number of protons and neutrons. So if my protons plus my neutrons equals 96, then 96 minus my number of protons, or minus my atomic number, will give me the number of neutrons. And in this case, 54 neutrons. All right, isotope notation. So recall that isotopes have a different number of neutrons, but the same number of protons, so they're the same element. In order to distinguish one atom of that element from another, we need to write it a little differently. For example, here are 3 isotopes of hydrogen. Using the abbreviation H for each of these really just doesn't give us enough information. So to write an isotope more clearly, we're going to write the element symbol, in this case H, followed by the mass number. And recall the mass number is the number of protons and neutrons. So this is going to be a little different than what you're used to seeing, but I want you to practice. So for this first one, I have 1. There are no neutrons, so my isotope notation for this would be H1, the element symbol and the mass number, 1. So here I have 2 particles, so the mass number would be 2, so it would be H2. Here I have 3 particles, 2 neutrons, 1 proton, so my mass number would be 3, so the isotope notation would be H3. Okay, you're used to getting this notation and going backwards. I want you to remember how to get there, and in that sense, you should be able to undo it later. All right, so let's practice. Here are 3 atoms. And I want you to write the isotope notation for each of these 3 atoms. It shows you the structure, the protons, neutrons, and in this case, the electrons. So I want just a hint to recall that lithium is abbreviated Li and has 3 protons. So take a moment and take a look at this. And if you need to stop it at this point so that you can practice on your own, please do so. Okay, so I have 3 protons in all of these, so they are distinctly isotopes. In this case, I have 3 neutrons, so I have a total of 6 particles in the nucleus. So this is lithium-6, Li6. Here I have 4 neutrons and 3 protons. My mass number is 7. That is lithium-7. Here I have 3 protons and 5 neutrons, so this is lithium-8. Okay, I'm going to go through the answers on this one a little more quickly. You'll need to pause it. I don't want the video to run too long, so I'm going to go ahead and go through this. So look at each set of atoms and determine if they're isotopes or atoms of different elements. So here's A, here's B, here's C, D, and E. And good idea to pause it and go over those yourself before you get the answers. But here we go. All right, so these are different elements. The number of protons are different. And then if you take a look down here, these are all isotopes. The neutrons are all different, but the protons are all the same. So B through E are all isotopes. Okay. So for atom 1, if we take a look at this, and we said that it had 18 electrons, would this be an ion? 18 electrons, atom 1 here on part A. Would it be an ion if it had 18 electrons? Yeah, it would. And hovering over here was probably not very fair in a way, but you have to watch. This says neutrons. We compare our protons and electrons. So if I have 17 electrons, I would be neutral. But I don't. I have 18, and so I have one more electron, so it's a negative ion. All right, so let's take a look at this one here. This one here. If I have 20 electrons, is it an ion? And the answer to that question is no, it's neutral. Here's my number of protons, 20. So I would have 20 electrons, 20 protons. I would be neutral. Okay, so hopefully that is good practice for you. And go on to the next review.